everyone, and welcome back to the deep dive. This is where we, take a different look at health, try to get past the usual stuff, and really understand how our bodies work. And today, we're tackling something that, well, it might genuinely surprise you, something that could challenge some pretty deeply held beliefs you might have about, like, fitness and nutrition. If you're someone who's, meticulously counting every single gram of protein, or you're religiously downing those shakes, forcing down chicken breast, or maybe just feeling kind of tied to a really rigid diet, tracking everything like your life depends on it, then this deep dive, honestly, it might just set you free. It's going to offer a really liberating new perspective. Our mission today, basically, is to unpack why this whole narrative, this idea that more protein equals more muscle, better metabolism, better health, why that's not just like an oversimplification, but why it's often, frankly, metabolically ignorant, or at least counterproductive. We're looking at this through the bioenergetic lens, basically, understanding how your body actually creates and uses energy at a fundamental level. We've touched on this framework before, right? When we talked about why certain fats, PUFAs, can be so problematic, or why energy itself, not just calories, is so central to health. And the gut metabolism connection, that was a big one. Plus, sugars, rehabilitation, debunking cholesterol myths, getting free from that obsessive salt restriction. So yeah, this builds on all that. So get ready to maybe question some things you've heard, maybe from fitness influencers, maybe certain nutritionists, maybe even, that guy at the gym. We're going to look at some very persistent ideas and see how they actually stack up against, well, biology.
Yeah, and what's really interesting, I think, is just how much the standard advice gets this wrong. Like, fundamentally misunderstands how our bodies work on an energy level, the actual biochemistry. We're going to pull back the curtain on some pretty surprising facts today. Reveal what your body really does with all that protein, especially when there's too much of it. It's way more complex and honestly way more costly to your system than most people ever realize.
Yeah.
We'll show you why trying to just force more protein often ends up working against your body's own wisdom.
Okay, so let's dive headfirst into this. This protein obsession, it really feels like for decades now, especially in fitness culture, protein's been crowned the absolute king, right? The undisputed macronutrient.
Yeah.
You look at the popular advice and the numbers are just staggering. 1 gram per pound of body weight. That's considered baseline by many. Sometimes it's even pushed to 1.5, even 2 grams per pound. Just think about that for a second. A 180-pound person, that could be 180 grams, or even up to like 360 grams of protein a day. It's pushed as this non-negotiable thing for anyone serious about muscle or strength or even just, general health and weight loss. But what do you think made it such a monarch, especially when like historical diets look so different?
That's a really good question, and it's deeply ingrained for a few reasons, I think. Part of it is definitely the marketing. Let's be real. The supplement industry.
Oh, huge, yeah.
Protein powders, bars, shakes, they've made it seem essential and super easy to consume in large amounts. Then there's the satiety factor. Protein does make you feel full, physically full.
Right, that feeling of fullness.
And for a lot of people, that feeling equals weight control or managing hunger. And of course, there's the basic truth. Protein is needed for muscle repair, for growth. That's fundamental. But the interpretation got skewed somewhere along the way. It became more is always better, completely overlooking, the body's actual requirements. And importantly, the metabolic consequences when you go way over those requirements. This really simple view just kind of bulldozed over centuries of how humans actually ate.
Yeah, exactly. And when you zoom out, like you said, look at ancestral wisdom or even traditional populations living today, this modern dogma starts to look pretty flimsy. Our ancestors, these traditional groups, they often ate way less protein than we're told to, but their health metrics, often incredible. It really throws a wrench in that high protein is automatically superior idea. Let's look at some specific examples. Like the Kitavans, they're known for just exceptional metabolic health, right? Vibrant energy, zero obesity in their population.
Amazing health, yeah.
And their protein intake, around 10% of their calories, 10%. Their diet was super rich in starchy tubers, yams, taro, plus fruits, coconuts, some fish. They were active, strong, robust, basically no Western diseases, all on what we'd now call low protein.
It's a stark contrast.
Totally. Or think about the Hadza in Tanzania, one of the last true hunter-gatherer groups. They're incredibly lean, strong, metabolically super healthy.
Right.
Their protein intake, around 15 to 20% of calories. Often lean game meat, sure, but crucially balanced with huge amounts of wild tubers, berries, honey, depending on the season.
That balance is key.
And even the Maasai, famous for their animal-based diet, right? Milk, blood, meat.
Yeah, people often point to them for high protein.
But even they only got about 19% of their calories from protein, and their health for their environment was remarkable. Plus, they weren't just eating chicken breasts. They consumed, more parts of the animal, giving a broader nutrient profile.
And that's the really profound insight here, isn't it? All these groups, excellent muscle mass, strong bones, fantastic metabolic health, all while eating way less protein than modern advice screams at us. It immediately makes you ask, okay, what's wrong with this more is better picture? And when you dig into the biochemistry, it gets even clearer why the modern way is, well, problematic. See, your body just can't store extra protein, not like it stores carbs, as glycogen in your liver and muscles.
Right.
Or like it stores fat in adipose tissue. So every single gram of protein you eat beyond what your body immediately needs for structure, enzymes, hormones, that sort of thing, has to be processed right then and there.
Okay, so it can't just hang around.
No waiting list.
Yeah.
No storage locker for amino acids.
Yeah.
Which brings up that crucial question. What does the body actually do with all that excess? Because it doesn't just vanish. And that processing is not neutral. It's actually incredibly metabolically expensive. It takes a serious chunk of your body's energy budget.
Yeah.
And that has knock-on effects down the line.
Okay, let's unpack that. The metabolic cost. So you eat a lot of protein, maybe more than you need for immediate building and repair. What's the first step? The body has to deal with it. You mentioned deamination.
Exactly. Protein deamination, that's step one for the excess. Basically, it means stripping the nitrogen part, specifically the amino group, off the amino acid molecule. This happens mainly in the liver. Think of it like you've got these complex building blocks, the amino acids.
Uh-huh.
The body needs some for building. But when you have way too many, it has to dismantle the leftovers. And that dismantling process leaves behind, well, metabolic debris that needs cleaning up.
Okay, so breaking it down. But you said it's costly.
Right. That deamination process itself requires energy. It's not free. And worse, it produces a byproduct that's actually toxic. Ammonia.
Ammonia, like cleaning product ammonia.
Chemically similar, yeah. And it's highly poisonous to your system, especially your brain.
Yeah.
So your liver then has to jump in again, work even harder, spend more energy to convert that toxic ammonia into something safer, which is urea.
Urea, okay, I've heard of that.
Right.
Yeah, urea can then be filtered out by your kidneys and excreted in urine. But this whole chain deamination producing ammonia, then the urea cycle converting ammonia, it's a constant...
It's a stress on the system.
A direct metabolic burden. The more excess protein you eat, the harder your liver and kidneys are working, just detoxifying and converting. It's a hidden cost most people chasing high protein numbers never even consider. They think they're doing something purely beneficial.
Wow. Okay, so that's just dealing with the nitrogen part. That alone sounds like a lot of work.
It is, and that's honestly just scratching the surface because the metabolic cost actually gets worse. Once you strip off that nitrogen, that amino group, what you're left with is called a carbon skeleton. Basically, the rest of the amino acid molecule.
Right.
Now, this carbon skeleton, this deaminated protein, often gets converted into glucose, sugar, through a process called gluconeogenesis.
Gluconeogenesis. Yeah, we talked about that when we discussed sugar, right? Making glucose from things that aren't carbs.
Exactly. It's the body making glucose from protein or from lactate or parts of fat molecules. But here's the crucial point. Doing it from protein is the hard way to make glucose.
The hard way.
Yeah, it's fundamentally a stress pathway. It's a survival mechanism the body uses when readily available carbs are scarce. Think about it. Metabolizing dietary carbs for energy. That's clean, efficient, straightforward. Gluconeogenesis from protein, that's driven primarily by catabolic hormones, stress hormones, like cortisol.
Cortisol, okay, so relying on protein for energy actually increases stress hormones.
It forces the body down that pathway. You're essentially making your body engage in this energy-consuming, stress-inducing process just to get fuel. Instead of just giving it the fuel it prefers, like dietary carbohydrates.
That seems backwards.
It's the definition of metabolic inefficiency. Get this.
Yeah.
Your body basically throws away about 33% of the potential calories in protein just in the process of converting it to glucose.
A third. Lost.
Gone. Just in conversion costs. Compare that to using dietary glucose directly, which is almost 100% efficient. It's like, imagine trying to power your house by converting firewood into natural gas first, losing a third of the heat potential in the process instead of just using the natural gas line directly.
That's a huge waste of energy.
It is. Biochemically, it involves the urea cycle handling the nitrogen, like we said, in the liver and kidneys, and then converting those carbon skeletons into glucose precursors. It's intricate chemistry. But the big picture takeaway, it's incredibly energy intensive. It puts a massive workload on your vital organs, forcing them to do metabolic gymnastics just to handle the excess protein instead of letting them focus on, repair, maintenance, other vital functions.
And the hormonal side effects you mentioned, cortisol, that sounds like it could really mess things up.
Oh, absolutely. The hormonal cascade triggered by chronically high protein intake.
Mm-hmm.
It can be really counterproductive, especially for the goals most people have when they eat high protein.
Like building muscle or getting leaner?
Exactly. So high protein intake tends to stimulate the hormone glucagon. Now, glucagon has important roles, like raising blood sugar when it drops too low.
Right.
But chronically elevated glucagon, it's essentially the physiological opposite of insulin. Insulin is your main anabolic hormone. It drives nutrients into cells, signals growth, tissue repair. It's about building up.
Okay.
Glucagon, on the other hand, generally promotes a more catabolic state, breaking down stored energy, mobilizing fuel.
So high protein means high glucagon, which opposes insulin.
Which means you're constantly pushing your body towards a breakdown state, hormonally speaking, even while you're desperately trying to build muscle by eating all that protein.
Wow. The irony.
Pretty stark, yeah. Especially for fitness folks.
Is there research backing this up, like studies on people eating tons of protein?
Definitely. Studies on protein overfeeding consistently show some worrying patterns. Increased cortisol levels, there's that stress hormone again. Decreased active thyroid hormone, will definitely come back to that connection. It's huge. And impaired insulin sensitivity, meaning your cells don't respond as well to insulin signal. Put it all together. High stress, low thyroid, poor insulin sensitivity. That's the exact metabolic environment that prevents efficient muscle growth.
So it actually makes it harder to build muscle.
It hinders it. It promotes inflammation, and frankly, it accelerates aging processes. Your body is essentially screaming for clean, efficient energy, and you're feeding it something that requires this huge metabolic effort to convert, which then triggers this cascade of hormonal responses that actively work against your goals and your overall health.
You know, hearing you lay all that out, the biochemistry, the hormones, it makes me think of this client I worked with a while back. Young guy, just 28, competitive bodybuilder, super dedicated.
Yeah.
I mean, this guy was the definition of discipline, hitting his macros perfectly, tracking everything, and he was pushing like 300 grams of protein a day, religiously.
Wow, 300 grams. That's a lot.
A ton. But underneath that, that exterior of dedication, he was just falling apart. He was constantly exhausted, like deep, bone-tired exhaustion. Always cold, like his hands and feet were ice.
Classic low thyroid symptoms.
Totally. His sleep was terrible, just awful, riddled with anxiety, and his hair was starting to thin noticeably.
At 28?
At 28, it was actually heartbreaking to see because he was trying so hard to be healthy and build his physique. We ran some labs, and yeah, just as you'd expect from what we're discussing, his cortisol through the roof. And his thyroid markers, especially his active T3 hormone, tanked, severely low.
The exact pattern. High stress, low metabolic rate.
He was basically aging himself rapidly. So we decided, okay, let's try applying these bioenergetic principles. We drastically cut his protein, took him down to about 100 grams a day, still plenty for his lean mass,
But more reasonable.
And we dramatically increased his carbohydrates. Lots of fruit, honey, white rice, easy to digest stuff.
Giving his body the fuel it wanted.
And the change, it was honestly remarkable. Almost overnight, he started saying he felt human again. His energy just surged back. His sleep became deep, restorative. His anxiety, way down. He actually started feeling warm again.
The biofeedback doesn't lie.
And here's the kicker. He started gaining muscle again while getting leaner. He broke through these plateaus he'd been stuck on for months.
That's incredible. Less protein, more muscle.
Exactly. It just hammered home how much our bodies prioritize efficient energy and how counterproductive forcing all that protein can be. He finally started working with his biology, instead of fighting against it.
Right.
And the results were just undeniable.
That story is such a perfect illustration of why we absolutely need to look beyond just the quantity of protein. We have to consider the quality and, crucially, the balance.
Yeah.
Especially the amino acid balance.
Amino acid balance. Okay.
This is something the modern fitness world almost completely ignores. They push isolated protein sources, like whey or casein or just lean meats, without thinking about the whole picture. See, protein isn't just one thing. It's made up of different amino acids, right? They each have specific roles, specific interactions. And one amino acid that becomes particularly problematic when you eat too much of it, especially relative to others, is methionine.
Methionine. Okay, where do we find that?
It's found in really high concentrations in what we typically think of as good protein sources, muscle meats. So Lean chicken breast, lean beef, most types of fish. They're packed with methionine.
But isn't it essential? Like, don't we need it?
It is essential, yes. Your body can't make it. You have to get it from food. We definitely need some. But the problem is excess. Too much methionine, especially when it's not balanced by other amino acids, is actually pro-aging.
Pro-aging? How?
Well, research clearly shows high methionine intake increases oxidative stress that's damage from free radicals. It also messes with critical methylation pathways. Methylation is vital for, like, detoxification, repairing cells, even turning genes on and off properly.
Okay, so it causes stress and disrupts key processes.
Exactly. And maybe most strikingly, studies have shown that diets high in methionine actually decrease lifespan. And basically every organism they've studied this in yeast, worms, flies, mice.
Wow. Decreases lifespan. That's significant.
It is, and it raises that question again. What did our ancestors know or do intuitively about balancing nutrients that we've just completely lost?
Right, because traditional diets weren't usually just lean muscle meat.
Precisely. Traditional dietary patterns often got this balance right, probably without even thinking about it. They naturally balance those methionine-rich muscle meats with foods that are rich in another crucial amino acid.
Glycine.
Glycine. Okay, what does that do? And where is it found? Glycine is amazing. It's found abundantly in things like bone broth, animal skin, gelatin, connective tissues, the odd bits we often discard now. And it acts almost like an antidote to excess methionine. It counteracts many of its negative effects. Glycine is strongly anti-inflammatory. It supports liver detox pathways, helps make glutathione, which is your body's master antioxidant. It even improves sleep quality, helps calm the nervous system. It's incredibly beneficial.
So methionine is high in muscle meat. Glycine is high in connective tissue, skin, bones. And modern diets are all about the lean muscle meat, throwing away the glycine-rich parts.
Exactly. We've created this huge imbalance. We're told, eat lean chicken breast, eat lean fish, which loads us up with methionine. But we've abandoned the traditional wisdom of eating the whole animal or using the bones for broth or eating the skin. We've ditched the glycine.
So we're getting the skewed ratio, all methionine, no glycine.
Pretty much. And according to the science, that imbalance literally accelerates aging processes and puts a strain on our detoxification systems.
It's like trying to build something complex with only half the necessary parts, and the missing parts are actually protective.
That's a great analogy.
Yeah.
And the research specifically on methionine restriction, deliberately lowering methionine intake, is mind-blowing.
What does that show?
Animals on lower methionine diets, they live longer, significantly longer, up to 40% in some studies.
40% longer lifespan, just from lowering one amino acid.
It's profound. And it's not just about living longer. They also show much better insulin sensitivity, less oxidative stress, and their mitochondria, the energy factories in our cells, function better.
Better energy production, less damage, better blood sugar control. Sounds like the opposite of what high protein often causes.
Precisely. Yet, modern advice keeps pushing more and more methionine-rich proteins, completely oblivious to this crucial balance. It's a major disconnect.
Okay, so practically, what's the ideal balance? How much glycine do we need relative to methionine?
For optimal cellular health, a good target to aim for is a glycine to methionine ratio of at least 1:1. Ideally, maybe even 2:1, favoring glycine.
2 parts glycine for every 1 part methionine.
Or at least equal amounts.
Okay.
This means consciously bringing glycine back into the diet, add collagen peptides to your coffee or tea, make real, long-simmered bone broth a regular thing. Choose cuts of meat with the skin on or connective tissue. Use gelatin in cooking.
So balancing it out.
Or the simpler approach. Just eat less overall protein, especially from those very high methionine muscle meats. And get more energy from carbs, which spares protein anyway. This rebalancing act can have huge effects on your cellular health, your energy, maybe even your longevity. It's about working with your biology.
This ties in so perfectly with something else we talk about constantly in the bioenergetic model, thyroid function.
Absolutely. The link is direct and crucial.
Because high-protein diets, especially when they're low in carbs, are notorious thyroid suppressors. The mechanisms are super clear.
Yeah, there are a couple of main ways it happens.
Okay, first, like we already covered, that excess protein forces gluconeogenesis, right? Making glucose the hard way.
Right, the stressful pathway.
And that process bumps up cortisol, the main stress hormone. And we know from talking about stress before that chronic cortisol is terrible for the thyroid.
Devastating.
It directly suppresses TSH. That's the signal from your brain telling the thyroid to work. And maybe even more importantly, it messes up the conversion of the inactive thyroid hormone, T4, into the active form, T3.
Which is the one that actually runs your metabolism.
Exactly. T3 is the gas pedal for your metabolism. High cortisol puts the brakes on converting T4 into T3.
So that's the indirect effect via stress hormones.
Right. But there's also a more direct hit happening right in the liver. Your liver needs stored glucose glycogen to do that T4 to T3 conversion efficiently.
Glycogen is the fuel for the conversion enzyme, essentially.
Right. Think of it like a factory. T4 is the raw material, T3 is the finished product, and glycogen is the energy needed to run the factory machinery.
Good analogy.
So if you're eating high protein and low carb, your liver glycogen stores are likely to be low, right?
Constantly depleted, yeah.
Which means that factory doesn't have enough fuel. The conversion of T4 to active T3 slows right down.
Impaired thyroid hormone activation.
Exactly. So you might even have enough T4 floating around, but you can't activate it properly. Your metabolism stalls.
And this studies back this up quite dramatically, don't they?
Yeah, it's pretty startling. Research consistently shows that when protein intake goes above roughly 25% of total calories, T3 levels tend to drop.
Active T3, the metabolic master switch.
Yep. So people trying to get lean or build muscle by pushing protein over that threshold are often actively lowering their metabolic rate.
It makes perfect sense from the bioenergetic view. The body needs readily available energy, primarily carbs, to keep the thyroid humming. Healthy thyroid function then supports everything else: energy production, protein synthesis, temperature regulation. When you connect the dots, it's like the body is screaming, "Give me fuel, real fuel, not just building blocks I have to stressfully convert."
And we see this exact pattern play out all the time with clients, don't we?
Constantly. It's so common.
Especially women, often trying to tone up, maybe lose that last bit of stubborn weight. They're told, eat protein at every meal, avoid carbs.
The standard flawed advice.
So they do it diligently. Lean protein, veggies, maybe some healthy fats, very few carbs. And they come to us saying, I'm always freezing cold, I have no energy, my hair is falling out.
Yep. Exhausted, cold, losing hair.
And I cannot lose weight, even though I'm barely eating, like 1,200 calories a day, mostly protein.
It's incredibly frustrating for them.
And when we look at their labs, it's almost always the same story. High reverse T3, that's the inactive form that actually blocks T3 receptors. Low free T3, the active stuff. And maybe normal TSH, or even low normal because the cortisol is suppressing it.
Their metabolism is just crawling. They've inadvertently shut it down by prioritizing protein over energy.
Exactly. They're stuck in this low-energy hypothyroid state induced by their diet.
So practically speaking, what's a better target range for protein based on this bioenergetic understanding?
Generally, for most women, somewhere in the range of, say, 50 to 80 grams per day seems to be a sweet spot. Enough for structural needs, enzyme production, all that, but not so much that it creates that metabolic burden and suppresses thyroid.
Okay, 50 to 80 for women. And for men?
For most men, maybe around 70 to 120 grams. Again, depends on lean mass, activity level, but generally in that ballpark.
Significantly less than the 1 gram per pound rule often dictates.
Way less for many people. But the absolute key isn't just hitting those numbers. It's ensuring that the rest of your calories, the majority of your energy, comes from those easy-to-digest carbohydrates.
Fruit, honey, juice, white rice, potatoes.
Yes. That's what provides the direct, efficient fuel your body needs to run properly, support the thyroid, and actually use the protein effectively.
Creating that environment of energy abundance for the cells, not scarcity.
Exactly. Abundance, not burden.
Yeah.
Okay, but let's tackle one of the biggest pushbacks we get, the classic one. But protein keeps me full. People swear by it for satiety.
Right. And it's true. Protein is satiating. But we need to dig into what that kind of satiety really is.
Okay. What do you mean, what kind?
Well, protein is generally harder to digest than carbs or even fats.
Yeah.
Takes longer to break down, sits in the stomach longer.
Right, it feels heavy.
Exactly. It creates a physical sensation of fullness, maybe even slight distension. Your stomach feels full.
And people interpret that as, I'm satisfied, I don't need to eat.
Correct. But here's the crucial distinction, is that true satiety at the cellular level, or just physical fullness in the stomach.
Ah, okay, so it could be a false sense of satiety.
Often, yes. While your stomach feels physically full, your cells might actually be screaming for readily usable energy. You end up in this state of being full but tired.
Full but tired. Yeah, I've heard people describe that.
Or satisfied but cold, or not hungry but my brain feels foggy. That's not true cellular satisfaction. That's often just digestive burden masking a deeper body-wide energy deficit.
So what's true satiety then from this bioenergetic view?
True satiety comes when your cells actually have enough energy, easily available energy. When you provide adequate calories, primarily from easily digested carbs, your cells get fueled efficiently. Blood sugar becomes stable. Your thyroid stays active and happy. Your nervous system calms down. That's when you feel truly satisfied and energized, nourished, not just physically stuffed.
Makes sense. So that constant nagging hunger or those intense cravings people get, even after a big protein meal.
Often that's not a signal for more protein. It's a powerful signal of cellular energy deficiency. The body is saying, hey, I need fuel I can actually use easily. Give me some carbs.
Right. It needs the quick energy, not more building blocks that take effort to convert.
Exactly, which
Huh.
leads us right into debunking another huge myth.
Let me guess. Protein is anabolic.
Bingo. The idea that protein itself inherently drives muscle growth and therefore more protein automatically equals more muscle. The fitness industry narrative is basically shovel in the protein, muscles appear.
Yeah, that's the gospel.
But viewed through this bioenergetic lens, it's fundamentally flawed.
Okay, so if protein isn't the main driver of anabolism, muscle building, what is?
Two key players, primarily hormones, insulin and thyroid hormone.
Insulin. But isn't that the fat storage hormone everyone fears?
That's another massive misunderstanding we should tackle sometime. Insulin, when functioning properly in an energy-sufficient environment, is arguably the most anabolic hormone in your body.
More anabolic than testosterone.
In terms of driving nutrients into cells and stimulating protein synthesis, yes, it's like the key that unlocks the cell doors. It pushes amino acids into muscle cells, it stimulates the machinery that builds protein, and it prevents muscle protein breakdown.
Okay, so insulin is crucial for building. And what stimulates insulin most effectively?
Carbohydrates. Easily digestible carbohydrates provide that healthy, appropriate insulin signal.
So without enough carbs, you're missing that key anabolic signal from insulin.
You're missing a major driver. It's like having bricks, amino acids,
Mm-hmm.
but no mortar and no brick layers, insulin and energy, to actually build the wall.
Makes sense. And the second driver, thyroid hormone.
Yep. Active T3, specifically. Thyroid hormone sets your overall metabolic rate. It determines how efficiently your cells produce energy and synthesize proteins. A healthy thyroid function means your body is in building and repair mode. Every cell has the energy it needs for its job, including muscle cells repairing and growing.
And conversely, low thyroid.
Low thyroid state, which remember can be caused by excess protein, and low carbs means sluggish metabolism, impaired protein synthesis. You simply can't build muscle effectively in a low thyroid state, no matter how much protein you eat. The capacity isn't there.
So the hormonal environment is key.
Absolutely critical, and the research confirms this. Studies comparing moderate protein with adequate carbs versus high protein with low carbs. They consistently show better muscle retention and often better muscle growth in the group getting adequate carbs.
Even with less protein.
Yes, because they created a superior hormonal environment, better insulin signaling, better thyroid function that actually supports anabolism and efficient energy use.
So how much protein is actually needed for muscle growth then, if it's not about maximizing it?
It's surprisingly little, according to research looking at nitrogen balance and muscle protein synthesis. Somewhere around 0.6 to 0.8 grams per pound of lean body mass. Not total weight, lean mass.
0.6 to 0.8 grams per pound of lean mass. That's way less than 1.5 or 2 grams per pound of total weight.
Much less for most people, and that range is typically plenty, even for athletes training hard. The key is getting the rest of your calories, the energy needed to fuel the process and create the right hormonal state from those easy-to-digest carbs.
It sounds so different from mainstream advice, but biochemically it makes perfect sense.
It does, and it's not even a new idea, really.
What do you mean?
Look back at the old-school bodybuilders, guys from the 40s, 50s, even 60s. Think Steve Reeves, Reg Park.
Yeah, incredible physiques. Classic aesthetic look.
Absolutely. And how did they eat? They didn't have whey protein isolate or BCAA powder.
Right, none of that existed.
They ate real food. Lots of meat, eggs, dairy, yes, but also plenty of carbohydrates. Potatoes, rice, fruit, honey, milk. They intuitively understood that energy was crucial for building muscle, not just hammering protein in isolation.
They were kind of living the bioenergetic principles without naming them.
Effectively, yes. They focused on whole foods that provided both the building blocks and the abundant energy needed to assemble them. It worked pretty well for them.
That's a great point. And it links back to those long-lived populations too, doesn't it?
Perfectly. Let's revisit them. The centenarians, the blue zones, the Okinawans before their diet changed drastically. Around 9% protein, mostly from sweet potatoes, some soy, tiny bits of pork maybe.
9%, wow.
The Nicoyans in Costa Rica, around 12% protein. Diet centered on beans, corn tortillas, squash.
Still very low by modern standards.
For the Sardinians in Italy, maybe up to 15% protein, lots of whole grains, vegetables, some sheep or goat milk products. None of these groups, known for longevity and vitality into old age, were pounding protein shakes or obsessing about hitting 150 grams a day.
Yet they maintained muscle mass, cognitive function. They were thriving.
Absolutely. What they did have in common was getting the vast majority of their energy from carbohydrate-rich whole foods, roots, tubers, grains, fruits, vegetables. Animal protein was often a smaller part of the diet, and crucially, when they did eat it, they often used the whole animal. Nose-to-tail eating.
Right, getting that glycine balance naturally.
Exactly. Broths from bones, eating organ meats, using gelatinous cuts. They naturally balanced the amino acids without meticulously tracking ratios. They weren't wasting parts of the animal. They instinctively created a complete nutritional profile that supported both structure and metabolic efficiency.
It's such a contrast to today.
Stark contrast.
Yeah.
Modern protein obsession gives us powders stripped of cofactors, lean meats missing the glycine.
Yeah.
Huge quantities that just overwhelm our detox pathways and stress our system.
We took something simple, get enough protein for structure, and made it complicated, expensive, and often metabolically harmful.
While the centenarians showed us the power of simplicity, real food, energy from carbs, moderate protein, balanced nutrients, working with biology.
It's a powerful lesson. Okay, so let's bring it home for everyone listening. Practical application. What should people actually do?
All right, step 1, recalculate your protein needs based on lean mass, not total weight.
Okay, crucial difference.
So find your approximate body fat percentage. Subtract fat mass from total weight to get lean mass. Then aim for that 0.6 to 0.8 grams of protein per pound, or about 1.3 to 1.8 grams per kilogram of lean mass.
Let's do a quick example. Say 180 pounds, 20% body fat.
Okay, 20% of 180 is 36 pounds of fat. So 180 minus 36 is 144 pounds of lean mass. Multiply 144 by more 0.6 and 0.8. You get a range of about 86 to 115 grams of protein per day.
86 to 115 grams. That's potentially half what that person might have been told to eat based on total weight.
Exactly. For many, it's a huge freeing reduction. That's step 1. Step 2, prioritize quality whole food protein sources.
Not all protein is equal.
Definitely not. Eggs are fantastic. Great amino acid profile, easy to digest fats, lots of nutrients. Dairy, if tolerated milk, cheese, yogurt, excellent protein, balanced, contains growth factors. Shellfish oysters, mussels, shrimp, super nutrient dense, good amino balance, trace minerals, and crucially, remember the methionine to glycine balance. Don't just eat muscle meat.
Bring back the glycine.
Yes. Incorporate gelatin, collagen peptides, homemade bone broth regularly. Eat chicken with the skin on sometimes. Use tougher cuts for stews. Balance it out.
Okay, calculate based on lean mass. Focus on quality whole foods, balance amino acids. What's next?
Step 3, be intelligent but flexible with timing. It's fine to have a serving of protein at each meal, sure, but don't force it down if you're not feeling it.
Listen to your body.
Absolutely. If you wake up craving fruit and honey, have fruit and honey. Your body might be asking for quick energy.
So no need to rigidly force protein into every single meal or snack.
No. Maybe you have eggs and fruit for breakfast. Maybe some fish with rice and veggies for lunch. Maybe beef stew with potatoes for dinner. It's about adequacy over the day, not rigid rules. Tune into your body's signals.
Okay. And step 4. This feels like the big one based on our conversation.
It is the absolute cornerstone. Step 4, fill the rest of your calories with easy-to-digest carbohydrates.
This is where the energy comes from.
This is the fuel your body actually wants. Fruit, ripe fruit, fruit juices, honey, maple syrup, white rice, potatoes, well-cooked root vegetables, maybe some properly prepared sourdough bread if tolerated.
Give your body the direct, efficient energy it's asking for.
Stop forcing it to do that stressful, inefficient conversion from protein. The shift from relying on protein for false satiety and stressful energy to embracing carbs as your primary fuel is often the most transformative change people make.
Allows the thyroid to work, gives cells energy, reduces stress.
Everything starts working better.
And how do people know it's working? What should they track?
Forget the scale initially, maybe. Focus on biofeedback, your body's signals.
Okay, like what?
Monitor your waking body temperature and pulse. As your metabolism improves, they should ideally rise slightly and stabilize. Feeling warmer is a great sign.
Warmer hands and feet, too.
Yes, consistently warmer hands and feet. No more icy fingers and toes. That indicates better circulation and thyroid function.
What about energy levels?
Should become much more stable. Fewer crashes, less reliance on caffeine or stimulants just to get through the day. Just steady, calm energy.
And sleep.
Sleep quality should significantly improve. Falling asleep easier, staying asleep,
Yeah.
waking up feeling genuinely rested.
So temperature, pulse, warmth, energy stability, sleep quality. Those are the real markers of metabolic healing.
Those are the signs your body is moving out of that stress-suppressed state and into a thriving, energized one.
It really boils down to simplicity, doesn't it?
Fundamentally, yes. We've just made it needlessly complex. Protein is for structure. Muscles, enzymes, hormones, skin, hair, building blocks. Carbohydrates are for energy. Fuel. The body's preferred clean-burning fuel. When you try to force the building blocks to be the primary fuel source, you create metabolic chaos, stress, inefficiency.
And the fitness industry loves complexity.
Complexity sells. Powders, pills, protocols. It makes people feel they need external solutions, makes them dependent.
Keeps them buying stuff.
Exactly.
Right.
But true health, especially viewed bioenergetically, is often much simpler. Real food, appropriate amounts, energy when you need it, rest when you need it, supporting your body's natural cycle.
Not constantly fighting against them with arbitrary rules.
Right. Your body's incredibly intelligent. It knows how much protein it needs for repair. It knows when it's low on energy. This constant obsession with tracking every gram, forcing food down to hit numbers, that's often not health.
It can become orthorexia, right? That fixation on correct eating.
Yeah, orthorexia disguised as optimization. And
Yeah.
it creates its own mental and metabolic stress.
So the message is, trust your biology more.
Trust your signals. If you're craving fruit, maybe you need energy. If you're always cold despite eating perfectly, maybe your approach isn't perfect for your metabolism.
If you need 3 coffees to function.
That's a massive sign of cellular energy deficit. No matter how much protein you ate, listen to those signals. They're profound wisdom.
Look, I get this might be challenging for people to hear. It goes against so much mainstream advice.
It really does.
But the biochemistry, the physiology, the ancestral evidence, the client results, it all points in this direction.
Excessive protein isn't the metabolic magic bullet it's claimed to be. It can be a significant stressor.
It can age you faster, suppress your thyroid, hinder muscle growth, make you tired and cold.
Exactly. So if you've been following that conventional high-protein advice and you're still struggling,
Still dealing with low energy, poor sleep, stubborn weight, those frustrating plateaus.
maybe this offers a different path, a reason why.
You probably came here because what you were doing wasn't quite working or felt unsustainable. You're tired of being tired, right?
Fed up with feeling full but simultaneously drained.
You want to feel vibrant again, alive, energetic.
Well, consider this your permission slip. Permission to stop the madness.
Permission to step off the high-protein treadmill and try a different way, one that actually aligns with your biology.
So let's quickly recap the core message.
Okay. Moderate your protein enough for structure based on lean mass, not excessive amounts.
Right. Embrace carbohydrates, easy to digest ones, as your primary efficient fuel source. Give your body the energy it craves.
Support your thyroid, which happens naturally when you provide enough energy and reduce metabolic stress.
And trust your hunger, trust your cravings, trust your body's biofeedback signals. Learn its language again.
This isn't about being lazy or giving up. It's the opposite. It's about working smarter with your biology, not constantly battling against it.
Allowing your body to finally heal, build, and thrive optimally.
And thinking about metabolic stress, this actually sets us up perfectly for our next deep dive.
Oh yeah, where are we heading next?
We're going to tackle exercise. What if I told you that your workout routine, the thing you think is making you fitter, might actually be creating too much metabolic stress?
Ooh, controversial.
What if less could actually be more when it comes to training for metabolic health? We're going to rethink fitness.
Interesting. Looking forward to that.
But for today, on protein, any final thought for our listeners?
Just that. What's really fascinating is seeing how the body's own intelligence just takes over and thrives when you finally give it the right conditions. Enough efficient fuel, balanced nutrients, it functions beautifully without needing all these rigid external rules we impose.
Yeah.
And it makes you wonder, doesn't it, beyond just nutrition, what other areas of our lives are we overcomplicating? Where might simplicity, trusting natural rhythms, and just less forceful effort actually be the real path to thriving? Something to think about.
Definitely something to think about.
You didn't come here today for more rules. You came looking for truth, for understanding. And the truth is, your body desperately wants to thrive. It's programmed for health and energy. You just need to stop forcing it into submission with things like excessive protein and start supporting it. Give it the real bioenergetic nutrition it needs. Let it do its thing.